our focus for this class is the velocity time graph, as you can see on your screen. So velocity time graphs has more useful applications in our day-to-day activities or in practice compared to the displacement time graph. Of course, the understanding of displacement time graph will give us a clearer picture of what the velocity time graph is talking about. In this case, the magnitude of acceleration at any point of a particle's motion can be depicted from the velocity time graph. So invariably, velocity time graph shows the acceleration of a body. That is a likely exam question. So the velocity time graph just permit me to write PTG. Okay, velocity time graph shows the acceleration of a body or the acceleration of an object. Okay, now let us consider the graph below. Okay, if we have that, okay, let's call this V and let us call this time T. Okay, or small letter t, whichever way. And t is measured in seconds, while velocity is measured in meters per seconds. I'm sure by now you know that. All right, let's say the particle's motion started from point O, all right, and accelerated to a particular point. Okay, this is point A. Okay, and then moves at a constant velocity. Okay, and what we use to denote constant velocity in physics is a straight line. So it moves with a constant velocity to a particular point. This is point A and this is point B. Okay, let's use the same color. So point B. All right, now from this point it's accelerated a little. Okay, it moves upward a little to a point C and then continues. Of course, you realize that this other motion is not a straight line, it shows a curve. Okay, to a point, let's call this point D. Okay, now we can decide to deduce the gradient of each of those points. All right, so if this comes down, remember it moves, and the distance from point O to point L, that's the time taken, let's call this L. Okay, let's call this L, and then the movement of this motion from of the object from point B to point C, let us say it maintains this path, okay, to point M, and then this point from point B to point C, it travels with this time N, and then the motion continues this way and then comes down. This point, let us call this point P, and let us call this point Q. All these points O, L, M, N, P, and Q, they show the time taken or the time interval to complete these motions A, B, C, and the rest. Of course, we can call this point X. Okay, so how can we analyze the motion of this object we have seen above? Okay, now considering the gradient, remember the gradient of the velocity time graph gives the acceleration. Please take note of that. That we have the uniform acceleration. It's called the uniform acceleration OA. Okay, it is explained by this point O to point A. Okay, it is equal to the velocity change all over the time taken for the change to occur. Right? And of course, I said earlier that the acceleration is equal to the gradient of the velocity time graph. This is also a likely exam question. They could ask you, what is the acceleration of a body, or what does the acceleration of a body symbolize, or how can we express it? It is expressed as the gradient of the velocity time graph. Okay, so the gradient of OAL, okay, is given by AL all over OL. Remember, gradient is the distance covered divided by the time. Okay, so it covers the distance OA. Okay, it covers this down OA and then within the time OL. Is that okay? So the gradient of this particular motion, this motion to this point, is equal to AL all over OA. All right. So if we consider at point B, at this particular point, the gradient is equal to Cn all over Mn. And how do we get that? Cn all over Mn. This could be approximated. Okay, this could be approximated to a straight line. Okay, so the gradient at this point is seen as Cn all over Mn. All right, and the third gradient you can see from this graph is the gradient xq, gradient xq all over pq. Okay, so the distance from this point to this point, which is what? Xq. Okay, which is seen as xq all over the time taken, which is pq. All right, so you realize that it is the distance all over the time, and the distance AL, all over the time taken, okay, for the motion. These are just pictorial representations of the uniform acceleration of a particular body undergoing this motion. All right, but some of the things you need to understand is that the gradient of the velocity time graph is equal to the acceleration of the body. So in conclusion, before I end the class, I would like you to note the following, that from this graph we have over here, from the graph AB, where can we locate AB? AB is seen, this is AB, all right? AB, let me write it out. AB is seen as a uniform or constant velocity. And we said when a body undergoes uniform or constant velocity, there is no acceleration. Okay, you realize that the body did not accelerate, it's just moving on a straight line. Acceleration at this point is equal to 0. So A is equal to 0 at this point, right? And of course, if A is equal to 0, the gradient is also equal to 0, right? We should also note that the velocity time graph represented by BC. Where is BC on the graph? Okay, this point over here, okay, represented by BC, is seen as a line. BC is a line with a steeper gradient than the first gradient we considered, which is OA. So BC is more steeper than OA, and so the acceleration at this region BC is always greater than that of OA. All right, is greater than that of OA, because the steeper the surface, the more the acceleration. Okay, the steeper the surface, the more the acceleration. And the next thing I would like you to note from this graph over here is that when the graph shows an irregular velocity change, okay, as we can see along CD, okay, from C to D, you will realize that the velocity is irregular. It is not straight, and that was how we represented it with a curve, okay, as opposed to OA that shows a very straight, it's a straight line motion. Okay, so when the velocity changes, when there is an irregularity in the velocity, then we say that the acceleration at point C, acceleration at X, okay, is equal to the gradient of the tangent to the curve. Okay, so the first thing, if we would have to calculate the acceleration, okay, at point X, so we have to find the tangent, and you know that tangent is a straight line that touches a curve at a particular point. All right, and this point, let us call it point X. The point could be here. All right, the point could be here, it could be here, but we decided to put it at point what? Point X. So we have to find the tangent to this particular curve, okay, the tangent, which is a straight line that touches a particular curve on one spot or at a point. So we find the tangent of the curve, okay, to be able to get the gradient of that particular motion. All right, so this is where we would wrap it up for the discussion under the velocity time graph. This is just a background knowledge, okay? In our subsequent class, we will solve problems under the velocity time graph so that you'll be able to have a full understanding of the concept. So see you in our next class.